our goal is to create two polynomials in factored form that could go with the following table. So when you're thinking about what your answer should roughly look like, you should think about number 3, where we were given a polynomial in factored form that we had to graph. We're going to create a function that looks kind of like that, but that would match this table. So this table has 4 sections, 1, 2, 3, 4. And we split up sections of polynomials using x-intercepts. So that means we have an x-intercept at -3, 4, and 7. So we should create factors that match that. So for -3, we would make a factor x plus 3. For +4, we'd make a factor x minus 4. And for +7, x minus 7. So currently, as this is a degree 1, 2, 3 polynomial, which means it would have in behavior down, up, but it's going to cross at each x-intercept, meaning that we're going to change signs. So it would go from negative up to positive, down to negative, up to positive. And what we want is we don't want a sign change. We want to go from negative, then cross positive. So what that tells us is we have a bounce at -3 and a bounce at 4. Try that again, bounce at 4. So we need to make our multiplicities of those factors even so that that does not cause a sign change at those zeros. So just really quick to make the connection, let's graph this. So I have an x-intercept at -3, I have an x-intercept at 4, and then 5, 6, 7. Okay. It starts negative, it bounces, and it crosses. So let's connect this to the table. Negative, negative. And then between -3 and 4, it's negative. It's negative, it bounces, it stays negative. So it's still negative. Okay, what about between 4 and 7? Well, at 4, it bounces and stays negative, so we're still negative between 4 and 7, but then after 7, we're positive. We're negative, 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 positive. Negative, 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 positive. Now, to make a different function that will do the same thing, we just need to include the same factors, but just give them different multiplicities that will cause a similar behavior. So instead of making this x plus 3 squared, I'll just make it x plus 3 to the 4th. And then x minus 4 squared would work. And then if I want to switch it up even more, I could make this cubed, because a multiplicity of 3 is still going to cause a sign change at 7, just now it's going to be a shoulder. So this polynomial will also match this table that was given.